This video will include many different learning targets. All are very concept-based, very definition-based, so that's why I want to give it to you all on video so that you can get your own definitions down, and then in class we will apply them. So qualitative is a description, where quantitative is an actual number. Accuracy and precision are not new words for you, but they might be new scientific concepts. When it comes to measurements, we can actually describe our measurements in one of two ways. Either that your measurement is accurate or that your measurement is precise. The difference between them is very important in terms of a measurement. So precision is how close all of your numbers are to one another, where accuracy is how close your average is to the actual number that you're trying to get. So if you look at these four targets on the screen, the first one you can see all four of the shots on the target are grouped in one area, which means they are very precise. The measurements are close to one another, but it's also accurate because it's on the bullseye. The second one, if you look, the four are not near each other, so that is not a precise situation, but it is accurate. Because if you took the average of those, you would probably get the bullseye. The third one is very precise. All four of your measurements are grouped, but they are not on the target, so they are not accurate. And then the last one is neither accurate nor precise. Now, in terms of chemistry or science in general, of course, we are trying to achieve accuracy. We're trying to get the right answer. But the truth is, in terms of scientific practice, you need to report precision. Okay? It's silly if you get the right number once if it's not repeatable. All experiments need to be repeatable. So accuracy and precision are both very important. There is another definition of precision that we use in science, and that is a measurement of how well the number is known. What I mean by that is how many places within any digit do you know the value of the measurement. So, for example, do you know it to the ones? Like, is it 101 or is it just somewhere around 100? Do you know if it's 101.2? Because that's more precise because you know more values. 101.25, that's even more precise because you know more values. So how well the number is known means how many placeholders do you have a value for that you were able to measure. 101.255, we're getting very precise there because we actually know our measurement all the way down to the thousandth. Okay? So precision is how well you know the number, going to essentially how small is your potential error. If you know the number to the tens, if you know the number to the thousandth, that's another measure of precision. Now, when it comes to measuring, we use a system that's called the SI system. You've used it before. It's the metric system, okay? And we use it instead of the English version. And it's simply because when it comes to conversions, you memorize one system for all types of measurements, and you're done, okay? So in the English system, you know that 12 inches is a foot and 3 feet are a yard, and then most of you know a conversion with miles to feet too. They're all different. If you memorize the SI system or the metric system, they're all based on the prefix base 10. So whether you're measuring distance or time or volume, they'll all have that base 10. And so that's what the value is for us. When it comes to the units we'll use then, when we do length, we'll measure it in meters. Mass is in kilograms is the base unit. We mostly measure in grams because of just the size of material that we're using. Time is seconds. Temperature is a measurement called Kelvin. We'll talk about here in a little bit. And then the amount of a substance is a mole, and that is very important in chemistry, this amount of a substance. Mass is not really amount of a substance. Okay, mole is how much in terms of a count, how much substance you have. Those are base units. Those are units we can actually go into lab and measure. We can measure a mole. We can measure temperature. We can measure mass. We'll also have some what's called derived units. And those are units that we can't measure, but instead if we use a calculation, we can arrive at. For example, density. Density is not something in lab that you can walk in and measure because density is mass divided by volume. You can measure mass, you can measure volume, but to get density you need to divide them. And that's why it's a derived unit. It's a unit that we have to do a calculation for rather than simply measure with a measuring tool. On the bottom derived list, we'll definitely use density. We use energy, which is measured in joules. In this class, we use pressure. There's lots of different units for pressure, but this one has pascals. And we use volume. Volume is actually a derived unit. You wouldn't think so because you can just measure volume, but it's actually length times width times height is how you get volume. Luckily, we have measurement tools for volume, so we don't have to derive it every time because that would be tedious, but volume is considered a derived unit. The next topic to cover is temperature. Temperature is something we'll measure often and use in calculations. We're used to daily reporting of Fahrenheit, but of course in science we use the SI system, and the SI system uses Kelvin. You probably haven't used Kelvin before, but you are aware of Celsius, and we'll be using Celsius in lab to measure. Temperature by definition is a measure of the average kinetic energy of the system. So kinetic energy is motion energy, so temperature is actually a measure of how much particles are moving. Okay, and they're an average, so they take an average of all the motion, and that is your temperature. You probably know a little bit about the Celsius scale, the fact that 0 Celsius is freezing of water, 100 Celsius is boiling of water. Okay. Because temperature is a measure of average kinetic energy and that has to do with motion, when we talk about particles and particle motion, scientists actually created a scale called the Kelvin scale. And the deal with the Kelvin scale is that 0 actually means something. So 0 on the Celsius scale means that's where water freezes. But if we're talking about motion, the question was, can we make a scale where 0 is absolute, where there's no motion there, and then throw a scale that has to do with increasing motion? And that's what Kelvin is. Okay? 1 degree change on Celsius is 1 change on Kelvin. Okay. And the relationship between them is that if you know the degrees Celsius, you just add the value of 273 to it, and that gets you to Kelvin. So at negative 273 degrees Celsius, that is absolute 0. That is Kelvin. So at 1 Kelvin, you're at negative 272 degrees Celsius. Okay. So to convert between the two, again, it's just that magic 273. If you know it's like 30 degrees Celsius outside, add 273 to it, you know that's actually 303 Kelvin. Okay. We'll talk about absolute 0 in class in terms of the ability to reach absolute 0, but you need to be able to convert between the two. We won't use Fahrenheit at all. Density is another measurement that we use a lot because it's a physical property of matter that is unique to any substance. So every single substance has its own unique density. You can use it actually to identify a substance. You've probably used density before. Density is simply mass divided by volume. Most frequently, we've got grams then divided by milliliters or liters in order to talk about density. The fact that density is unique for every substance is something called an intensive property. That means it doesn't matter how much of the material you have or where it came from, the density will be the same. So because the relationship between the amount of the substance and the volume, if you increase the amount, you increase the volume, and they're relative to one another. Things like mass and volume alone are not intensive properties though, because if you have 20 grams of something and then increase it to 40 grams of something, those masses aren't constant, they change. Okay, same with volume, same with temperature. Those are something called extensive properties that are not constant for any substance. Intensive properties are something that are. So like boiling points, densities, regardless of the amount of material, you will have that one value given. Here's density written as equation, mass over volume. Simple as that. Because it is a derived value, it has multiple different units it could potentially be, because mass is measured lots of ways and volume is measured lots of ways. Again, most common for us will be grams per mil or grams per liter. But just take a look at those because that determines a lot about your substance, what your units are. The last thing for this video is how to calculate percent error. So percent error is the percent that your value is away from what the expected value was. So the expected value is frequently called the theoretical value. That's a value that in a perfect scenario, that's what we would hope to get. The actual value is a value that you measure in lab. So the actual value is not something you can calculate or something that can be given to you from a reference manual or a book. The actual value is something that is lab driven. So to calculate a percent error, you take what you hope to get, which is your theoretical value, and you subtract away from it what you actually got. So you figure out what the difference between your two numbers are, and then you divide that by your theoretical value and times it by 100, and that will be your percent error. Okay? those are all these main beginning concepts. There's a couple others, qualitative, quantitative, and scientific notation, that you can use the supplemental video for, or hopefully you already know them. So go ahead and do the form for this video and have a nice night.